In 2019, Amazon quietly shut down an algorithm called Project Nessie. Between 2014 and 2019, it had raised prices on more than 8 million items and waited, monitoring whether Walmart, Target, or smaller rivals would follow. When they did, Amazon held the new price. Federal Trade Commission documents call it deliberate inducement. Executives called it, privately, an unspoken cancer. The FTC trial begins October 2026. That deadline reshapes the question every enterprise pricing team is quietly avoiding. Not whether the algorithm produced results, but whether it can be explained. Opaque, wrapper-dependent AI is no longer a technical liability, it is a legal one. This paper's argument is direct. Sovereign intelligence, built on auditable VPC-resident architectures, is the only architecture that survives what comes next. Most enterprise pricing systems run on what the paper calls the wrapper trap, thin application layers built atop public APIs through a single massive prompt. 4 critical failures emerge. First, auditability. When a black box model makes a pricing decision, the enterprise cannot reconstruct why. Second, predictability. A vendor's model drift can silently change outcomes without warning. Third, compliance. Public APIs carry no governance model. They are susceptible to jailbreaks and tone drift. Fourth, cost and latency from inflated token usage make the approach unscalable for real-time market interactions. But the structural failure runs deeper. Simple rule-based competitors operate on deterministic logic. If competitor lowers price, match it. That is exactly the behavior a reinforcement learning agent learns to exploit. A Carnegie Mellon University study lays out the mechanism precisely. A reinforcement learning pricing agent operates as a Markov decision process, or MDP. The state is a snapshot of the market, current prices, demand signals, inventory levels. The action is a price adjustment. The reward is profit. The agent iterates across millions of simulations, learning the optimal policy, the strategy that maximizes expected discounted return across all future states. Formally, the optimal policy equals the action that maximizes the expected sum of discounted future rewards. What Project Nessie discovered empirically, the CMU researchers confirmed formally. When a sophisticated RL agent competes against rule-based tit-for-tat systems, it identifies the competitor's deterministic pattern within a small number of iterations. It learns that raising its price leads, consistently, to the competitor matching it. The agent requires no communication, no explicit agreement. The reward function does the work. The paper extends this analysis to recursive Markov decision processes, hierarchical models where a category-level agent recursively invokes SKU-level subagents. Each layer optimizes independently, but the combined effect creates persistent, deeply structured pricing coordination that traditional antitrust surveillance cannot detect. The latest evolution is reasoning AI agents that use extra computation at inference time to simulate multiple moves ahead before committing. A reasoning AI pricing agent plans several steps forward, models how competitors will react, then backtracks from suboptimal paths before any price changes in the real market. The system's internal reasoning process may intentionally lead to extractive outcomes, and the trail is invisible to regulators. The evidence in the paper is concrete. Project Nessie set prices for more than 8 million individual items and extracted over $1 billion in excess consumer payments. Amazon activated the algorithm at least 8 times during high-traffic periods, cycling it deliberately to maximize extraction while reducing regulatory visibility. Internal documents contain an executive admission that the strategy was designed to, quote, deprive rivals of the ability to gain scale by offering lower prices. In September 2025, the FTC secured a $2.5 billion settlement, the largest in the agency's history for an algorithmic matter. The October 2026 trial addresses the remaining Sherman Act monopolization claims. State law is accelerating in parallel. California's amendments to the Cartwright Act, effective January 1, 2026. Define a pricing algorithm as common if it has 2 or more users drawing on competitor data, and lower the pleading standard so plaintiffs no longer need to exclude independent action at motion to dismiss. New York's transparency law, effective late 2025, requires a visible warning whenever an algorithm uses personal data to set prices. The mandate from this paper is architectural. A sovereign intelligence stack deploys the full inference layer inside the client's own virtual private cloud. Open-source models such as LLaMA3 or Mistral, orchestrated through VLLM, with all embeddings stored in a PostgreSQL database the enterprise owns. RBAC-aware retrieval augmented generation retrieves only what a user's role permits. A governed multi-agent system routes every output through a compliance agent before delivery. The paper's closing line stands on its own. In the post-Nessie era, the most valuable asset an enterprise can possess is an algorithm that is not just powerful, but provably its own. The white paper is available now on the Veriprajna platform. 15 pages, approximately 20 minutes for a technical reader. The FTC trial opens in October. The architecture questions this paper raises will not wait.